Hello, my dear students. Welcome to the introductory programming course. So let's see what are we going to learn today. The very first topic we'll be discussing is about computational thinking. And in this, we will discuss how we can address day-to-day problems and how can we think the way a machine thinks. And secondly, we are going to learn how to interact with these black boxes, also known as computers. So they may seem like a black box to you, but guys, they are pretty easy to interact with. And especially with modern technology, it has just become a child's play to interact with these seemingly complex machines. Next, we are going to learn that how the language of zeros and ones is the new lingua franca. So zeros and ones is the language that computers understand. And we are going to discuss a bit that how computers understand this language. Next, we are going to discuss how to become mini god with algorithms. That means how to master algorithms. And last but not least, we are going to discuss how computer science is the basis of modern day civilization. So before I move further, I would like to say that many of you may feel that computer science is esoteric, weird science discipline that only belongs to some other world. And that's quite obvious because, this field evolved so fast that, it was too fast for many to get comfortable with it. Also, there are so many layers of abstraction that people don't get to know how exactly computer works and how to talk to them, though they are definitely using one or the other computing device in their day-to-day life. So let's move on. That I mean, how can this course benefit you? So before you enroll in this course, remember that what ultimately matters in this course is not so much where you end up relative to your classmates, but where you end up relative to yourself when you began. So, if you're a beginner and fear that you may not live up to the expectation of this course, well, this course expects you to have high school mathematics knowledge, and I'm sure you all are good at it, right? So, it doesn't matter if you are naive to this field, you will learn how to think computationally. And if you already have a good knowledge of any programming language, then also picking up this course will brush up your skills by not just focusing on the syntax of any particular language, but by teaching you how to approach a problem rationally and how to have a problem solving approach rather than just learning the syntax and the rules of a particular language. So, computer science is ubiquitous and it has spread its wide wings across almost all the spheres of the world. So, if you hail from a strong physics background, so maybe computational physics allows you to study scientific problems using computational methods. So it may be helpful to you in case you are much interested in physics. It can combine computer science, physics, and applied mathematics to develop scientific solutions to complex problems. Now, if you say, I am from biology honors and biology is my favorite subject, how can this course help me? So, I would like to add on here that learning to code may assist you to develop graph algorithms for genome mapping and for certain types of DNA and peptide sequencing methods, and maybe pattern matching for various sequence search problems. Isn't that interesting? So, I am sure if you are a computer science enthusiast or you are a beginner, you are going to love this course. So, what do we mean by thinking computationally? So, by saying thinking computationally, I mean to say that you need to think in a very rational manner and you need to approach a problem in a way that you think a computer can understand. So, what is a computer? I think all of you know it's not just that box in front of which a whole lot of software engineers spend their entire day. So, if we closely observe, everything around us is has a computing device like a car is a computer. We have a navigation system there, not literally a computer box, but we have a navigation system there. And a dog, well, dog is not a computer, but maybe the dog collar. It can have a tracking system that is a computing device in itself, a pacemaker, washing machines, ovens, ACs. And in Japan, Even toilets have a computer, and there are even hackers who hack it. So eventually, Internet of Things will turn everything into a computer, from your toothbrush to bottles and everything you can think of. So, what are the principles of computational thinking? So, the very first principle is that you should think of every problem as a stack of simple, smaller problems. So, by this I mean that you should follow the divide and conquer approach. So, suppose you're organizing a party, you're assigning some task to one of your friend, or maybe music to another friend who's fond of music. And this way, you're dividing your problem and you glued up all the components. And here is the solution to your bigger problem. So, the second principle is recognizing patterns in real life problems. So, pattern recognition is really important to get the final output. So suppose when I used to learn knitting, so every time I used to, you know, took up my needle, I used to, in a repeated manner, I used to form those loops, and ultimately, what was the resultant? The result is good. It's a beautiful looking, uh, uh, maybe sweater or something, whatever you're knitting. So you need to recognize pattern and then repeat those patterns to achieve solution to your problems. So, how to now interact with computer? A programming language may be a solution to that. It's a perfect language between English and maths, right? So if I talk about maybe if you are a businessman and you have a product which you want to sell in different nations, and you want to convey the idea of your product to different people, so the concept behind your product, the idea behind your product is same, but what is different? The difference is how you are communicating that to different people. So by saying that, I mean that same thing can be implemented in different ways where the underlying concept remains the same. Similarly, here we have different programming languages: C, C++, Python. You may have heard of so many such languages. So, we have so many languages to achieve the same thing. It doesn't matter which language you use, but you should know what to do and how to do. And eventually, you can anytime learn syntax of a particular programming language and you can implement. But you need to know how to, think rationally, how to just uh, break down that complex problem into simpler sub problems, and how to just solve it. So code is the new universal language for this generation, the new millennial lingo. When you were a little kid, you used crayons to express yourself. You grew up as a teenager and you learned some musical instruments, and maybe via songs you were expressing yourself. So now you are grown ups, and you are finally after school and ready to learn a language that computers understand. So, the more approachable we think technology is, the more we play with systems, take them apart, we can tinker with them, the better sense of what's possible we have. And just like Bertrand Russell's perfectly mentioned that a programming language is a perfect language between English and math, and his lifelong quest to find an exact language between English and math found its home inside your computer. So, programming language allows you to write a program which is just a sequence of instructions that you give to your system, and you can write your program in any language of your choice. So, programming language is nothing but a special notation to write programs. This course tells you how to interact with the computer by writing your own programs. So, what is the food for our black box, for our programs, for our computers? So, data is the food for our black box. Data is on what our computers operate on. They take the data and they manipulate data, they analyze data, they find for patterns, they work on it, and they give us the final resultant output. So how does computer see data? 0 1 0 1 is a sequence of zeros and ones. As you all might have heard of binary, and even if you have not, don't worry, we are going to discuss it. But hold on your horses. First tell me, what is this? 1 2 3. What is this? How do you read that? This is a simple decimal number. How do you read this? You read it like 123. How are you doing that? So you are doing a mental calculation that place value of 1 is 100 and that of 2 is tens and 3 is ones, and you read it quickly. Well, a quick calculation. Each and every place value is power of 10 because this is decimal system and we have 10 numbers. That's why power of 10 is used to express this idea. Now, what do you think? How do computers read numbers? So maybe a computer wants to read number 5, so how is it going to do that? So we extend the same pattern that we just studied for decimal, and extending the same pattern here. Let's see, since binary system has two numbers, zeros and one, we choose power of 2. Here the base is 2, so you see how easy the language of computers is. Everything here is in power of 2, as you see here. Woohoo, it's the same principle. Let that sink in. And yes, don't worry. If you are not able to understand it right away, we are going to discuss it in detail, maybe in the upcoming lectures. And these zeros and ones are Legos of our data and used to represent almost everything. Isn't that so cool? Whole movie, just zeros and ones. Your Arijit Singh album of sad songs, maybe which you listen after your breakup, and even this emoji guy, they all are written in zeros and ones. So now what to do with all this data, that is millions of zeros and ones? Well, that's where algorithms come into picture to process the data. So they are in your phones, laptops, cars, house appliances, and whatever you can think of. They run stock markets. Bank is a gigantic tangle of algorithm. And they are running the human civilization. Now, how computer represents an algorithm? So let's see how you use algorithm in everyday life. I bet you all love music. Me too. You know the size of one song or HD video is 30 MB one song, and maybe 800 GB and even more a video size is. Isn't that shocking? Well, let's develop an algorithm to compress them. And this is how you will learn how to write simpler algorithms. So data compression, it is just about finding patterns. And the minute you recognize the pattern, you can write the algorithm and you can identify how you can compress that particular any text. Like consider this text. She sells seashells on the seashore. The shells that seashells, I'm sure. So if she sells seashells on the seashore, I'm sure that the shells are seashore shells. So I wasn't bad in reading this tongue twister. But what you notice here is that the text shell, seashore, she, they are repeated too often. So we need to compress this. Why? So as to save this data in minimum space, memory space. So here's a simple algorithm for data compression. In step one, we are associating a special symbol with words in the text that are repeatedly used, like hash with shells, a percentage sign with C, and an ampersand sign with she. So we are replacing this word in the text with symbols defined in step 1, and in step 3 we are repeating step 1 and 2 for each word in the text till the end of file is reached. So this is a simple algorithm how we are going to implement that, and let's see its demonstration. Here you see that we have these special symbols. This is the dictionary, as this is a symbol associated with each word. And if we notice here, the compressed text size is 130 bytes and the original size was 178 bytes. So we are achieving a compression of 18% here. Isn't that great? So a bit about programming constructs, if else, do until, while, case, for, don't worry. They are pretty simple and they are quite common to all the programming languages. So just like walking is iteration, walking is repeating, walking is an action we do in a loop. We don't think much about it, but you know, our bodies repeat many actions. Breathing, sleeping, eating, drinking, and walking, all are the actions that we repeat daily. So let's write an algorithm for that. How will we break down the steps? Step 1 is left foot forward, then right foot forward, repeat. So what is this? This is a loop. We are entering into a loop. We are walking continuously with our left foot, right foot forward, right? So this is how we write our algorithms. And let's see how we represent these algorithms graphically. Very simply, I would like to explain you here. If then else. So if the weather is pleasant, you are going to play, and if the weather is not pleasant, you will better sit at home and watch Netflix or so. So this is how computers represent, understand this if then else construct, and this is how using if then else you can just express the same thing. Do until. So until a condition is there, you are repeatedly doing certain things. So until you are reaching a particular condition, you are repeatedly moving in a loop round and round and round, while you still have some rasagullas on your plate. You keep on eating them till your plate is empty. So the condition here is the plate is not empty, and that's why you are eating in loop. And when the plate is empty, you're just exiting the loop case. So if you're going to temple, you are taking a different route. You're going to maybe some friend, you're following different rules. So if you have different choices to make, then you are going to use something like this construct, which is a popular switch case. And in case of for, you are repeatedly moving in a loop. We are repeatedly moving in a loop till your condition is satisfied. So this was about programming constructs. We have briefly discussed it, and in the course we are going to deeply discuss it. And this was all about basics of programming, algorithms, and here I would like to end the session. And before ending the session, I want to say that computer science doesn't exist in vacuum. It's not just about learning how to code while loops, or learning what loop is, or even about learning backtracking, but it's about solving problems, automating things that can be done, and if you want to be the part of the fourth industrial revolution, computer science will be the backbone of it. So you are not going to regret taking this course. Good luck, my dear students.